Hi, welcome to Learning Monkey. I am Raghuveer. In this class, we do some practice examples on permutations on alphabets. In our previous classes, we have done some examples. Please watch our previous classes and come back here because all these are continuation classes. Our assumption here also, you already know the previous basics. Based on that, explanation is provided here. The link for the playlist is provided in the description below. Coming to today's class, given some characters has been given, jagdise jagdise has been provided. So from this they are trying to ask some questions like this. Find the number of words. You need to find the number of words using these characters that starts with J and end with E. So from simple questions to complex questions, we move from simple to complex questions. So that starts with J and end with E. So how many characters are there? 1, 2, 3, 4, 5, 6, 7. Total 7 characters are there. So these 7 characters can be arranged in 7 different positions. In how many ways they are going to be arranged in 7 different positions? Using 7 factorial. These are all possible ways. You can arrange these 7 characters in 7 different positions. The all possible ways are 7 factorial. But here they are asking the first position should be filled with J and last position should be filled with E. Means J and E are fixed. And what are the remaining positions? 5 positions are there. What are the remaining elements? A, G, D, I, S. 5 positions and 5 elements are there. So 5 elements can be filled. You can arrange 5 elements in 5 positions in 5 factorial ways. This is the basic thing which we understand from our previous classes. 5 positions can be filled with 5 elements in 5 factorial ways. So total how many ways you are going to fill the number of words that start with J and end with E is 5 factorial words are present. Now coming to the second question, the same find the number of words that contain J, E to be on the extremes. Extremes means J, E should be on the starting and ending position. So here you need to understand J, E. This is one possibility. Either you can write it as E, J. So the first position and the last position can be filled in 2 different ways. One way is J, E. Other way is E, J. So in order to fill the first and last position, how many possibilities are there? 2 possibilities are there. 2 multiplied by Y multiplication. We already discussed it from our previous classes. 2 multiplied by, in between you can fill the remaining. What are the remaining characters? A, G, D, I, S can be filled with. In between we are having 5 positions. 5 characters has been provided. So 5 characters filled in 5 positions using 5 factorial ways. Total 2 multiplied by 5 factorial ways. Coming to the next question. Find the number of words that contains vowels in even positions. The vowel should be present in even positions. Total how many words are there? How many characters are there? J, A, G, D, I, S, E. 7 characters are there. You need 7 positions. 1, 2, 3, 4, 5, 6, 7. Even positions means second position, fourth position, sixth position. How many vowels are there? A, E, I, O, U are the vowels. A, I, E are present. Total 3 vowels are present. 3 even places are present here. Second position, fourth position and sixth position are the even positions. 3 vowels can be filled in 3 positions in 3 factorial ways. Yes, we fill these 3 positions in 3 factorial ways. How many consonants are there? Remaining are consonants. 4 consonants are there. So second position, fourth position, sixth position. If you remove that, what are the odd positions? 1, 3, 5, 7. 4 consonants are placed in 4 positions. You can fill that in 4 factorial ways. Total even positions filled in 3 factorial, odd positions filled in 4 factorial. So 3 factorial multiplied by 4 factorial. These are the ways, these many ways you are having you're having to place this, to arrange these characters by placing vowels in the even positions. Now coming to the next question, the number of words possible with J, E together. This is similar question from our previous examples, previous class examples, but there is a slight change. That's why we have chosen this example. J, E should be together means, so you have to combine J, E as a single element. J, A, G, D, I, S, E. In this, J, E should be together means J, E is considered as single element. So total how many elements are there? J, E considered as single element. 1, 2, 3, 4, 5, 6 elements are there. These 6 elements can be arranged in 6 positions. J, E together means J, E can be placed here, J, E can be placed here, J, E can be placed here, J, E can be any position you can place. So all these 6 elements can be arranged in 6 positions in 6 factorial ways. But there is a small slight change here. J, E should be together means you can write it as J, E or you can write it as E, J. It was not mentioned that J should be in the beginning, E should be in the end. J is the starting element and E is the next element. J, E should be together. That means you can write it as J, E or E, J. So in order to fill this position, this J, E can be arranged in 2 ways, either J, E or E, J. So that's why 2 multiplied by 6 factorial. So in order to make you better understanding, assume that this is one possibility. J, E, A, G, D, I, S. In this you can change E, J, A, G, D, I, S. Another possibility. If you place J, E here, A, G, D, I, S, J, E. Other possibility is E, J. Wherever you place J, E, you are having 2 possibilities. What is that? J, E, E, J. That's why this 6 factorial should be multiplied with 2. 2 multiplied by 6 factorial. These many possibilities are there in order to arrange these elements for the given condition. Similarly, the next one is important. The number of words possible with J, E not together. Identifying all these cases is very, very difficult. J, E not together means you can place J here, you can place E here. J, E is not together. You can place J here, you can place E here. J, E is not together. You can place J here, you can place E here. J, E is not together. So J, E should not be together. In this type of situation, we go with complement method. So J, E not together means total possible words minus J, E together words. If you subtract from the total, the value which you get here is J, E are not together. So total possible ways is, total how many characters are there? 7 characters. 7 characters filled in 7 positions, 7 factorial ways minus J, E together means 2 multiplied by 6 factorial, the above question. So these are the values where J, E not together. So these are the important examples you need to understand on alphabets. Hope you understand these examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.